In this video, we want to find the volume of the solid generated by revolving the region bounded by y equal the function square root of sine of x, y equals 0, x between 0 and pi, including 0 and pi. And this will be revolved or rotated about the x-axis. If you want to give this a try, go ahead and pause the video, and I'll be right back. Let me remind you of the formula for the disk method, which is what we're going to use on this particular video. At perpendicular rectangles, if the axis of revolution is horizontal, which it is in this video, for this problem, then the volume of the solid of revolution is given by this integral. The integral from a to b, pi out in front of the outer radius, capital R squared, minus the inner radius, little r squared, or lowercase r. Sometimes the r will be 0 if there's no hole in the solid of revolution. And that's going to be the case in this particular problem. And of course, if the axis of revolution is vertical, then everything is in terms of y. Got pi, integral from c to d. Now the outer radius is r squared of y minus lowercase r squared of y. And you can evaluate this integral. And this is what we have when the axis of revolution is horizontal. There's your region there. Now if it turns out that this section right here, or this region right here that we're looking at, coincides with the x-axis, then the r here is going to be 0. That's lowercase r. And dx, of course, is the thickness or the width or height of the cylinder. Let's look at this again. We got the curve. The region is formed by this particular curve, x between 0 and pi, or x greater than or equal to 0, less than or equal to pi, and y equal to 0, which of course is the x-axis. So notice, if I replace the x by 0, and this function, sine of 0 is 0, square root of 0 is 0. If I replace the x by pi, the sine of pi will be 0, the square root of 0 is 0. For any values in between 0 and pi, this is going to be positive. And then the square root of a positive will give me a positive. So this graph is going to be above the x-axis. So you got something that will look like this. So the region we're rotating is right here. So notice this is sitting right on the axis of symmetry. So if I draw my representative rectangle here, and let me clear this, using the disk method, so the rectangle here is real thin. I'm drawing it kind of thick here. So the capital R in the formula, where the outer radius goes from the x-axis to this point here, that's the square root of sine x. And that's your capital R. That's the outer radius. Like I said, if this had been somewhere up here like this, then you go from here to up here to get R, capital R, and from here to get little r, or lowercase r, and then you subtract those. But in this case, we're just dealing with one integral. So the volume is going to equal to, and again, this formula is based on the area for the volume of a circular cylinder. So it's going to be pi, and the integral, of course, is going to go on the x-axis. X is the integration variable from 0 to pi, so those are your limits of integration. And then it's capital R squared. Well, that's this right here. So that's the square root sine of x. No lowercase r here. Otherwise, we'd have a subtraction out over here for that. But in this case, this is just going to be dx. And then this is squared. This is equal to then pi, integral again from 0 to pi. Radical sine of x squared is just sine of x. And then we just integrate. This will be pi then. And then the integral of sine of x is minus cosine. So I'll put the minus out in front. Minus cosine. So minus cosine of x becomes a minus pi cosine of x. And then we integrate this then, or apply the limits of integration. from 0 to pi. So we evaluate first at the upper limit here, so this would be minus pi, cosine of pi, and then it's minus and minus pi, and cosine evaluated at the lower limit, cosine of 0. So we evaluate here, cosine of pi is -1 times the negative pi gives us a positive pi. And then it's minus over here, and then cosine of 0 is 1, and then times the minus pi is minus pi, but then we have a negative out here, so that makes it a plus pi. So we add these up then, pi plus pi is 2 pi, and this is the final answer. So the volume of the solid revolution rotated about the x-axis with the given information is 2 pi. Remember, this is a volume, so this will be cubic units. Thanks for watching. We'll see you next time.